I think the idea was to be listener rather than speaker. But what I'd like to do is to give us a little window at the end of this to take stock, entertain some questions. But I want to begin with thanking Citris, who without... There's no question that not only this day would not have happened, but this project wouldn't have taken place. If you think back, I can remember when this project came together. Many of us were in the midst of trying to figure out how to win the hub in energy-efficient buildings. We were pulling our hair out, going crazy, trying to get Berkeley and LBL and NREL and several other organizations and create a regional innovation center. I was talking with George about this earlier today. And in the midst of this, this was also when the economy was literally a question mark. And of course, the ARA structure was intended to bring together important industries and sources of innovation to try to move not only the state of the art forward, but the state of sustainability forward, and in doing that, create paths for a variety of new jobs and industrial opportunities. So it was a wild time. I think in the long run, I think to first off, let me take stock a little bit. A sense on a scale of from here to there, how much got accomplished in this project? A crude sense. Yeah, people are always afraid to raise their hands. I think it was, so in my own experience, we were bridging three very different cultures. We were bringing three very different agendas together around a common problem. It was fascinating as the conversations took place. There was a point where watching the Siemens slides presenting analysis using SMAP and its browser, and the back and forth as we dug into Ranjan's work on the Energy Plus model. Well, why is it like that? Because the Siemens folks said this, that, and the other thing, that there were some very deep interactions that went in kind of interwoven through the three organizations. So on the other hand, the goal of the project and the whole initiative was to create a base from which to move forward. And I think we got in the very last talk a sense of that. Really, I think the notion was to create some options. And I don't think it was a given that at the end of the project, Siemens would suddenly flip a whole new business unit up, stand it up, and away you go. But to have a technology base where they could seriously consider some options, and that conversation would not be limited to any particular company or any particular lab or university. So I think it has been an incredible journey. I think actually a tremendous amount has been accomplished. I'd like to take a minute to both get some opinions and some comments, questions, thoughts on the day. Carl, please.
Yeah, I love this project, but it's just in the middle in my mind. And the challenge particularly that were identified with the isolated systems, all these control loops that don't talk to each other is a huge challenge. And that the real savings are going to come from figuring out how to get control of the whole system. And we're just beginning to scratch the surface on that problem. We've got some great tools. This is a really well-instrumented building with some really good software operating it, but the control problem is just beginning.
Yeah.
So I'm looking forward to more projects that I love.
Well, we love that too. I can say, without question, this project both benefited from an ongoing effort to turn this building into a test bed. We wouldn't have been able to accomplish it if we hadn't done the things we did in Locale and Action Webs and the CEC building to grid test bed. We couldn't have started this. And vice versa, this gave a kind of focus to some of those initiatives. when I think of the things that are just getting started, so for example, there is a new NSF Cyber Physical Systems grant funded in software-defined buildings that's taking a family of what was done here and moving it forward to really programmable building. That's myself, Randy Katz, and Francesco Borriello. He has yet another buildings-related cyber physical systems NSF grant. I think there is a third. We barely touched on what's possible as FlexLab comes into existence and we begin to take the kind of representative and the highly controlled and bring those two worlds together. I think a useful question at this stage might be, what are some of the other next steps as we go from the middle to a longer future?
I thought one of the most interesting sort of opportunity areas was mentioned in the FlexLab presentation, and that was convening, I think they were described as horizontal and vertical public-private partnerships. Horizontal meaning like convening manufacturers to address sort of shared issues or opportunity areas, you know, for example, convening window manufacturers, and then vertical being sort of more project-based, is sort of like convening manufacturers to discuss within the context of an actual project, sort of the interplay of their respective products, is really, you know, sort of taking this work and sort of exploring sort of market opportunities with real players in the market.
Thoughts following up? With this project as well, there's an element of both that horizontal stratification and that vertical integration. It happened because there were two different backnet vendors and yet a need across a family of platforms. But also, if you look at the technology, it then migrated also to service Johnson Controls and automated logic and not just backnet, but ODC and reach out in other directions, just as one example.
Maybe it was in your slides, but who were the companies involved besides Siemens, and you just mentioned Johnson?
Yeah, this is a very interesting one in that the formal project structure was CIEE, i4Energy, LB&L, and Siemens. So in some sense, there was one industrial participant as a researcher in the project. The technology that was utilized in the project is much broader. Of course, each of those centers, the Demand Response Research Center, CIEE, i4Energy, deal with many, many companies. And I think that's an interesting question, how we begin to take some of this activity and bring that across those broader collaborations. And in fact, many companies participate in more than one of those. Other thoughts? I see some heads nodding. Marianne?
I was interested in your thoughts about, we talked a little about demand response versus energy efficiency and sort of continuous energy management. And one of the challenges is what the facility manager is paying on the bill each month. Because we didn't really talk about what the value was to, you know, UC Berkeley or the building owner or
right.
The economics of
the economics, the Carmonomics. It turns out that that's even one that's very timely. So after quite a bit of debate, there was recently a decision that now each of the buildings, in fact, each of the departments, as if those were one and the same, which, you know, we all know there are departments that span many buildings, there's buildings that span many departments, good luck. In any case, would be responsible going forward for their energy savings. And of course, you say that, and then you say, relative to what? And so immediately we have a situation, even for this building, where the baseline that was presented as the relative to what has nothing to do with anything we've measured. We happen to have measured it in incredibly detailed fashion, so we're prepared to have a discussion. But on the other hand, then you get into this question of, so is the goal to do better than a baseline, in which case you'd like to raise the baseline so that you can get all of the wowie-zowies about doing better, or is the real goal to use a whole lot less energy? And unfortunately, as part of bringing that economics in, first thing will happen is to raise the baseline so that you can do better than it when, you know, the Carmonomics say, regardless of how we've been doing. We want to continue to do better and better. I think one of the things that was really valuable in this project was that there was very genuine conversation around the real goal and the trade-offs between demand response, which is really about getting loads to be a more effective player relative to supplies, and energy efficiency, which is another kind of more effective using less, period. And there's a tendency for those to be viewed as intention, because of course, the less efficient you are, the more waste you have to throw away in order to be very responsive. But the right answer is not to use it in the first place, and then the thing that's so critical, to be agile about how you use it. And I think, although given the strict way it was formulated, 30% shavings on a hot day, there was a tendency to say, oh, well, we'll only be evaluated in our responsiveness, so let's not think about efficiency. When in fact, within the project, there was a really wise kind of concerted notion that, of course, you want to deal with those together. You want to be both efficient and agile. But I think we owe it to the broader community to reinforce the message that those are absolutely intertwined. And that, of course, the answer is both. You need to both be responsive to availability and extremely efficient about everything you use. And I think maybe that's an important follow-on for the project, is to articulate how those two are intertwined. No question, the ability to model, the ability to isolate where spend goes, to understand how it relates to pattern, those address both of those goals. And at best, it's a bureaucratic thing to separate them, since they're so interwoven.
The price of electricity at the end of the day, which is bought and sold in many ways, is you're going to pay until you go.
Right.
The campus does.
Right.
The DR programs, the ancillary services programs, all these things, at the end of the day, save money.
Save money and save emissions, and to the extent that the price, in fact, relates to the difficulty in production, you would hope that even those incentives become aligned as well, which of course is demand response formulated through critical peak pricing, is an approximation to making supply and demand match and also driving it down. George.
Yeah, I actually have the fortunate perspective of seeing 5 or 6 other projects just like this. The usual suspects are involved, and they all have their own secret sauce.
Mm-hmm.
Different kinds of modeling, different kinds of mapping, different kinds of control systems, different methodologies. The thing to keep in mind is that I was taken aback, well, actually not taken aback, I was disappointed in a statement that Steve Sothwitz made earlier, and I wasn't disappointed because it disappointed me in any other way than he's saying something that was stated 20 years ago, and we really haven't gotten very far. And I think the reason is because we have to think about this in a really new, dynamic way. Yeah, the things that the Siemens fellow said earlier about these are the things we have to do, and we have to do this market segmentation, all that sort of stuff. That's the way it has been done.
Yeah.
But it has to be questioned, is that the way we're going to do it in the future? Because as somebody recently said, the solution to integrating this whole monster is all of the above.
Yeah.
All the solutions that work, and everything should be thought out that way, so that any innovation that's done is delivered in many, many different ways. The investment that he made that's going to be required to upgrade these systems is billions of dollars. I don't want to surprise anybody, but the building owners are not going to pay for it. Mm-hmm. They're not going to. They have very different interests. So that means that we have to bring other people into the party who are going to help move this along for different reasons. Today, it's demand response and ancillary services. That's only because we can monetize that today.
Right.
There are many other services
right.
that are going to be way more valuable. That if we can deliver these things, get our buildings to work right, this whole thing will move forward in a really big way.
Yeah.
So it's important to make sure that you're thinking outside the box and not just trying to polish the same dusty car.
Right. Right. And I think there are elements within this that, for example, when we ask what are the millions and millions of dollars of environmental control technology in this building, including the plant as well, and then what's the marginal investment to make that significantly more intelligent, significantly more responsive. It may be scary how small that is. And having the fortitude to say, oh my gosh, yes, you really can put a control loop in Python. It doesn't have to be written in PLC that nobody can understand. And there can be a whole world of folks that are able really to do the analysis to reach all the way down. And that may be threatening to some entrenched industries, but that's okay too, because that's part of the forward progress. I think it is, I would say it is surprising how light the investment is once you get serious about the information technology to get a significantly different capability in operating. And on the other hand, packaging that up and delivering that meaningfully to the 120 million buildings in this country alone, that's a much different picture of how do we really get the friction out of that whole system. And that's really where it's all about, is not what we can do for any one building, but how do we scale that rapidly across the entire building stock? And how do we make some of those trade-offs? Yeah.
You don't want to say price, how much does it cost to run the building, but you could say what happens if the external temperature changes 10 degrees up? How much energy do you need?
Yeah,
I couldn't understand that today.
Right.
I was trying to learn from here, but I couldn't learn that.
That how much more would it cost if the world outside us changed?
How much energy percentage do you need?
Yeah.
What you consume today, if the outside temperature goes up by 10 degrees?
Yeah. Well, if the outside temperature goes up by 10 degrees, our problems are much greater than the increase in cost of running the building, of course.
Well, but you have an automated building, so it provides control.
It does, but
for you to survive.
Right.
Or make it 1 degree.
It'd be nice if sea level stayed somewhere near where it is. And
you're a chemist, you know what the specific.
Right. You know, of course, nobody's afraid to talk about price either. And you know, it's pretty simple. A megawatt's $1 million a year. A watt's $1 a year. It's really pretty simple. You know, that's plus or minus 12 cents a kilowatt.
That's a way of comparing, say, a good building from a bad building. You know, what's how does the requirement energy increases?
But I think part of what's in here, because there's much more to a building than just the thermal resistance of its envelope, which in some level is the start of that. And part of what you're seeing is, to what extent does this give us a handle on, for any building, how do we move its operating point either to be much more efficient, much more agile, much more comfortable, or really, ideally, all three of those, and with a very graceful trade-off amongst those. We do have the the slack variable, the marginal cost of running the building for every degree of change in outside air temperature. And in fact, buried into some of the slides is even a very nice model that will predict energy usage of the building as a function of outside air temperature, time of day, day of week, because it folds in all of the occupancy activity. So that actually is buried inside there. The number didn't pop out. But that's an example of applying some very natural machine learning to the data that's underneath it, is to produce that kind of sensitivity. And then you ask the question, how do I improve that? Right? Good. Question back there.
My name is James Sun, and you see the set. It's really nice to see that you guys are implementing validated control strategy. It's nice building Berkeley. But Berkeley, as you know, has the best weather in the country. So I really like to see that when a signal going on in the set. And the good news with Merced is that we're building new buildings all the time. And we have the science and engineering building is going up now, and we're going to have new buildings in the next 20 or 30 years. So it would be very nice that if we can implement a lot of control theories among the response controllers and a lot of new ideas, and Siemens technologies somehow implemented in new buildings. We can plan this early on. So I really like to Carl and Mary-Ann and get Merced involved. We have a large water. We have people really interested in work like this.
Yeah.
So that's my comment. Thank you.
It's a great comment. Thank you for bringing that out. Let me expand on that a little bit more. I have to confess, I grew up in Santa Barbara. So for me, I had to learn when I moved to Berkeley, there's a thing called a sweater, and it's good to put shoes on too. But I understand that out there in Merced, you know more than just what a sweater is. But Merced, of course, invested very deeply in the engineering and the design of the buildings to operate at a far more sustainable profile, addressing many of the harsher weather conditions that you talk about. So I think this is a terrific responsibility because in some sense, we get away with building a building like this in Berkeley because the weather is so nice. And now the question is, can we take the kind of technology here and move it to, I would say, far more intelligently designed buildings addressing a tougher challenge, namely the weather environment. And as well, and we've done quite a bit of work looking in the other direction of moving it into less intelligently designed buildings. So yes, we'd love to take you up on that offer. There's a seed project in place through i4Energy from Citris. There's some very nice work that's been done with Andrew Serpa, for example, in adjusting the set points. And now the question is, can you do the kind of things that we're doing down inside of the plants as well? So very natural. There's also work touched on very briefly with UC Davis. They have a more coordinated campus than we do. And so there's been work connected with his project to bring that in. We have UCs that are outside of the Citris umbrella, like Santa Barbara, that are doing very interesting work. If we take the 9 or 10, take the 10 UC campuses, we comprise 1% of California's energy spend. If we throw in the labs, we're getting closer to 2. The kind of things that we practice, actually practicing them seriously, could begin to make a real difference, one that you could measure in the state as a whole. So I guess that's a bit of a call to action to continue to come together across various boundaries. I think that's probably a great note to declare success, to thank Siemens, to thank LBL, CIEE, i4Energy, the Department of Energy, the good sense of the federal government to spend some money in this direction and cross our fingers that many of those go, no-go decisions you'll start agonizing and go, go Bears.